Okay, now taking this topic, combinations. The first question, which is an obvious question which can come to the mind of any mathematician, is this: that what is meant by combination? Okay. In mathematics, a combination is a selection of objects taken some or all at a time. So by combination, the keyword is selection. Okay. To add to this definition, we can also say it like this: whenever selection is made from a given number of objects and the order is not to be considered, then this process is known as combination. So after making a selection, if we have nothing to do with the order, meaning to say that we are not arranging it, then this process is known as combination. Okay, now we can take an example like this, that we have three letters X, Y, Z, and we have to select two letters. So then this can be done as XY, this can be done as YZ, and this can be done as ZX. Okay. So in this, an important thing is here that since we are selecting, then XY and YX both are same. YZ and ZY both are same. ZX and XZ both are same. So whenever the object is selected in such a manner that the order is not considered, then this is known as a combination. So the total number of combination of two letters selected from the total of three letters is equal to 3. Okay, so I hope the definition of combination is very clear. Okay, now we can also consider the difference between permutation and combination. In combination, only selection of R objects from the total of N objects is done. Okay, quite clear? Whereas in permutation, selection as well as arrangement is done for R objects taken from the total of N object is done. Okay, so combination is just selection, but permutation is also selection plus arrangement. Okay, this is writing the numbers in form of a set. Okay, or writing the elements in form of a set, and this is writing the elements in form of an ordered pair. And you know that in ordered pair 1 2 is unequal to 2 1. Okay, but in a set 1 2 is same as 2 1 because here order doesn't matter. Okay, now suppose that we select three objects. For example, these are the balls of different colors. Then if we are considering the permutation, then we are going to number the selection. Okay, 1 2 and 3. So if I change these numbers, okay, then the selection is going to become a different selection. In other words, this is an ordered list. And in combination is, as you can visualize from this example, is just like keeping object in some bag. And here permutation is keeping object in an ordered manner, that is giving a number to the certain objects. That is, an ordered list is prepared. Here we are preparing an ungrouped list, or simply object are placed in some unordered list. Okay, so here you can visualize the difference. So this visualization is sometimes necessary, because in some problems we don't get an idea it is a permutation or a combination problem. Okay, or maybe you can get confused. So always get to this point: is an ordered list is to be prepared? Yes, permutation; no, combination. Okay. Now we are going to take the theorem on relation between permutation and combination. Okay, the relation between permutation and combination is this: that NCR into R is equal to NPR. we have n objects from which r objects is to be selected. Then number of combinations of r objects from n objects into r factorial is equal to npr. Okay, now how we get this result? So this is a very easy result. It doesn't require any elaborate explanation. So its proof is going to be like this, that suppose we have selected r objects from the n objects. Okay, then each selection of r objects is going to produce r factorial number of arrangements also. Okay, so the total number of arrangements will be equal to NCR into r factorial. These are number of selection. Okay, and the of r objects from the n objects, if we multiply this by r factorial, we get what? We get arrangements also. Okay, so the selection into arrangements of the r objects which we have selected, it gives us the permutations of n objects from which r objects have been taken. So in this manner, we get NCR into r factorial as equal to NPR. Got it? So the key point is this, that each selection is going to produce r factorial arrangement. So NCR selections, that is total number of selections, are going to produce the total number of selection into r factorial arrangements. Okay. Now we are going to study the formula to calculate the total number of combinations. Okay. The total number of combinations of r objects from the total of n objects is given by NCR is equal to n factorial upon n minus r factorial into r factorial, where r is going to be less than equal to 0, greater than equal to 0 and less than equal to n. So how we get this result? So it's quite simple. Since NCR into r factorial is equal to NPR, we can write NPR as equal to n factorial into n minus r factorial. So NCR into r factorial is equal to NPR. So NCR is equal to, this on cross multiplication here will be equal to NCR. So total number of combinations is given by this formula.